how
Yeah,
the
it's
arc.
like how far you would have to walk from here to here. The arc distance for this point is going to be defined as how far you walk from the x-axis to that point if you go counterclockwise around the circle. Okay? Make sense? Okay, so let's just figure this out step by step. Arc distance what's the arc distance around the whole circle? Now this is a unit circle. What do I mean by unit circle? Somebody want to tell me? Or take a guess? Probably not a term you've seen, huh?
It shows all the trig functions.
It's what?
It shows like sine and cosine.
Well, we're going to use it to define the sine and cosine, but we use a unit circle to define the sine and cosine, but you can't define the unit circle as that circle you use to define the sine and cosine when we haven't defined the sine and cosine, right? So, you see the association, and that's very good, but that can't be used as a definition. But thanks for mentioning that, because that's what we're headed. Okay? Unit circle just means a circle with radius 1. You know, 1 is your unit, right? The number 1 can be referred to as the unit of counting. It's the unit. So this is a unit circle. It's a circle of radius 1, which we're going to use to define the sine and cosine. Now you can define sine and cosine by triangles, but we're not doing triangle trigonometry here. The only triangles we're using are right triangles that involve the Pythagorean theorem, and we've seen how we use those already. Okay? And that's just plain old 8th grade geometry. Actually, that's something you probably saw before 8th grade. Okay. So the arc distance around the whole circle is what?
Pi.
Again?
Pi.
You say pi, you say?
2 pi r.
2 pi. Well,
2
no, there's
pi
no
r.
r. R is 1.
2 pi r. That's the circumference around the circle.
No, it's not the circumference around the unit circle. What's r for the unit circle?
1.
So if r is 1, what's 2 pi r?
2 pi.
It's just 2 pi. You want to get that straight. We're on a unit circle. We're not on a circle of radius 10 anymore. If we're on that clock circle of radius 10 that we talked about, then it's 2 pi r, which is going to be 20 pi, right? Okay? Because remember, what's the definition of pi?
3.
Anybody remember the definition of pi?
Diameter.
I know,
It's the
but I
ratio
wanted to say
of
you're
circumference
saying
to diameter. Okay? Which means that the circumference is pi times the diameter, right? You can write that as a formula, but it's a concept.
What is,
Okay.
what is your official definition of pi?
It's the ratio of circumference to diameter. That is the definition of pi. It's a universal definition of pi. Okay?
Circumference over diameter?
Yeah. Yeah. Okay? An exercise I often do is we go out outside and we mark off 4 points at equal distances from some center
Let's do that.
by pacing it off, see how many paces, and then we pace around the circle, and we divide the number of paces around the circle by the number of paces across the circle, and we always end up with something like 3.1 or 3.2.
Are we doing that today?
I'm sorry?
When are we doing that?
We're not going to have time to do that. Too many other things to do. But it's something you can do yourself. You know, you can mark off those points and then walk a circle around them. Try to keep your paces consistent. If we average it over the whole class with the paces that people get, we get the ratio pi to within plus or minus 0.1. Okay? Okay. So anyhow, the arc distance around the whole circle, we will agree, is 2 pi for reasons that you should understand very well in terms of the definition of pi, right? So we kind of lock that in. We remember that, but we remember that we sometimes have to think about why that's true, so we don't lose track of the source of this whole thing. We take it all the way back to the definition of pi. Okay? Egyptians had that. Okay? You know, several thousand years ago. Okay, so arc distance around the whole circle is 2 pi. What's the arc distance? Around 1/12 of the circle.
2 pi over 12.
And that reduces to,
Pi over 6.
yeah. So it's 2 pi over 12, which is the way you want to write it, and then you notice that that reduces to pi over 6, right? Okay? Okay, well, in degrees, what angle does that correspond to?
30.
Well, 1/12 of 360 degrees is 30 degrees, right? So I'll just note in degrees, this is .30 and importantly, this cuts a 90-degree angle, or the right angle, into 3 equal segments, right? Now the right angle is 1/4 of a circle, right? So you could do 2 pi over 4, that gives you pi over 2. Well, I'll kind of draw that out of you for homework, but it's very simple. Do we agree this is very simple?
Yeah.
Now one reason we choose, I'm sorry.
I was gonna say the homework, I feel like it's how it's worded that makes it confusing, because like the concept seems simple, but then.
Yeah, well then you gotta know how to read the words, and that's really, I won't say it's half of being able to do mathematics, but you have to be able to deconstruct sentences and understand what the words mean. And of course, if some of the words haven't been defined and you don't have a good intuitive sense, then it gets difficult. Okay?
I think it's what takes so long, so we don't know how to work it.
Yeah, well, one thing I'm trying to get you to do is deconstruct the words, okay? Because you have to express things concisely and precisely, okay, in order to make the statement comprehensible. If the statement gets too wordy, you got to balance being too wordy with being too concise, okay? So, I totally understand. Of course, one of the reasons I get you to discuss things is so you can speculate on what some of those statements mean, okay? Because the statements I'm giving you here are very concise, but they all relate to concepts that you've seen. And we'll talk about that a little bit later. Okay, so anyhow, here we have arc distance in a circle, okay? That make sense? Well, this means that pi over 6 is just as good a measure of an angle corresponding to 1/12 of a circle as 30 degrees. Okay? So I'm just going to say okay? It's in red. If it's in red, it's really important. So if you look back over class notes videos, which are all a minute or less, you can see where the red things are and see things that you really, really, really want to be able to think through. Okay? So this is one way of measuring angle. This is another way. Okay? Engineers sometimes use grads. I don't even remember. I think there are 100 grads in a complete circle. 360 is a really good number to use. Because pi over 6 is an irrational number, right? You don't even want to see that in decimal form. It's pi over 6, okay? In decimal form, you wouldn't recognize it, and there's no reason you should. Unless there is, in which case, then start recognizing it. But yeah, I don't think you'll run into a case where you need to understand, the decimal equivalent of pi over 6. Okay? 360 is really convenient because 360 is what? 2 times 2 times 2 times 3 times 3 times 5, which means there are a lot of numbers that divide evenly into 360, so you can do a lot of even divisions of a circle in whole number degrees. Does that make any sense?
Yeah.
Yeah, it's really easy to divide 360 by a whole lot of numbers. Yeah.
Okay, where it says is just a good measure or whatever, is that supposed to be a good as?
It's just as good a measure.
As
Thank you.
good?
If I don't start writing all the letters, I'll make an as out of myself. Okay. Y'all don't understand puns well. Okay.
I got
But-
it. It was fine.
Okay. Oh, you just didn't think it was funny. That's okay. I got it.
I was
Yeah.
listening.
I feel better. Thank you. Okay. Now.
I didn't get it.
Okay.
If you add another S, he'll make an as out of himself.
Oh,
Got it now.
I got it.
Oh, now you really think it's funny because you're kind of smiling, or you're just smiling because you're proud of yourself for getting it. For whatever reason, I'm glad you're smiling. Okay. So anyhow, now. So I'm going to use theta, which is a symbol we typically use for angles. I'm going to use theta for the arc distance because I just said that arc distance is just as good a measure of angle as degrees. Matter of fact, if you're going to do calculus with sine and cosine functions, you really want to use this arc distance. Because if you measure in terms of this arc distance on the unit circle, the formulas for the rate of change of sine of theta or cosine theta are much simpler than they would be if you used degrees. It's the simplest possible measure of angle if you're going to do any real mathematics with the angle. On triangles, it's more convenient to think in terms of degrees, but when you're doing trigonometric functions, the functions that we're defining that you've already graphed, okay? You want to measure your angles in terms of the arc distance in the unit circle. And there's a name for that. I'm not going to confuse you with the name radians. That's what radians are.
I know what those are.
Huh?
I know what radians are.
You what?
I know what radians are.
Well, do you recognize this as radians?
Yes, that's
Yeah.
theta.
And of course you've had a trig course, and you've had a good trig course, and you know it well. So I'm glad you recognize it, and I would expect that you did. Those of you who've had a trig course, most of you haven't.
To get
Okay.
the degrees from radians.
I'm sorry?
To get the degrees from radians, you multiply by 180 over pi, and to get from...
Yeah, well, you get that right out of this. If 30 degrees corresponds to pi over 6, then you got to multiply pi over 6, or I'm sorry, yeah, by 180 over pi to get 30, right? Or you got to multiply 2 pi by 180 over pi to get 360 degrees, okay?
Yes, sir.
That's, yeah, no, those are conversions. And there's a reason for the conversions, and I hope you understand those conversions in terms of why they work. because again, you want to go down to the most fundamental level if you're going to understand things, okay? But enough talk about things that you only understand if you've had trigonometry. This is how we measure angles in mathematics if you're talking about trigonometric functions. You never talk about trigonometric functions that you're going to analyze in any way in terms of degrees. Now, there are exceptions when you're doing wave functions and stuff like that. You talk about 90-degree shifts and stuff, but, you know, we're not going to worry about that. Don't have time. If we had a couple more extra weeks, we could go into it, but you're going to see it if you haven't already. Okay, so if x and y are the coordinates of the point in the unit circle corresponding to arc distance theta, then the sine of theta is y. Sine is actually spelled S-I-N-I. Doesn't mean evil things.
S-I-N-E or S-I-N?
S-I-N, I said I, didn't I? S-I-N-E, yes, I can spell. And cosine, C-O-S-I-N-E. Okay? So now, if I was to mark off the unit circle in units of pi over 6, it would look like this. There's no pi over 6s, there's a pi over 6, there's a pi over 6. 3 of them makes a pi over 2, which is 190 degrees. 4 of them, 5 of them, 6 of them, 7, 8, 9, 10, 11, and 12 are back to the original one. Okay? Then you could easily estimate the coordinates of these points, couldn't you? And the estimates we ended up using, this point would be what? Well, that point corresponds to a point on the clock, right? That's 2 o'clock. What'd you get for 2 o'clock if this was a radius 10? Your estimate was 8 or 9, right? So 9 would be your estimate. So this is not a radius 10, this is radius 1, so this would be 0.9. And what's the other coordinate? On a radius 10, this point was 9, because it's 9 out here, and what here? 5. It's 9, 5. Now if you reduce to radius 1, it's 0.9, 0.5. Now that's just a single significant figure estimate of the sine, but it's pretty close. Okay? And this point is 0.59. What's this point? Well, you know, if this point projects here, then so does this point, doesn't it?
Wait, so pi over 6 would be 0.95, and then 2 pi over 6 would be 0.59. Oh no, 0.5.9.
Is that supposed to be
Yeah.
0.9 up there?
Yeah.
0.5, 0.9?
Yeah.
So,
Yeah, it's a bad 9, although I can tell what it is. Your distance, it might get a little blurry there, because it's a little blurry from here. Okay, so anyhow, this is 0.9, negative 0.5, right?
where are we getting the 0.9s and 0.5s from?
It's like
The estimates we made and the estimates, the numbers I asked you to use on the homework, I said do the coordinates of the points on the 10 radius clock in terms of the numbers 0, 5, 9, and 10. Remember that? So, you know, hopefully if you think about what it means while you're doing it, which you almost have to do if you do the problem, you're going to remember those numbers. By the time you get done with the problem, that'll be locked in. Okay? Okay. So down here you're going to have 0.5, negative 0.9. And this is for at pi over 6. Now what's this? What's the arc distance here? This arc is from here to here is pi over 6. What's this arc?
5, 3.
No, it's 2 pi over 6. Of course, that reduces to pi over 3. Yeah, just do it in multiples of pi over 6 and then reduce if you have to. Because otherwise, you have to think about why is it 3, why is it 2, why is it 4 pi over 3, all that. Just think in terms of, well, that's, 2 hours backwards on the clock from here. Well, that's 2 pi over 6. So I'll say at 2 pi over 6, and of course that equals pi over 3. And so forth. So we could label all of these angles, and of course, all these arcs, and of course that's going to be a homework problem, okay? So you get used to what these numbers are. And then you just do a graph, just like the graphs you all did really nice job on the other day, except we're not starting at 12 and counting 1, 2, 3, 4. We're starting at 0 here, counting 1 pi over 6, 2 pi over 6, 3 pi over 6, and so forth, right? Make sense? Okay.